All right, students, we're going to go ahead and take a look at the parent function checklist you received in class. You were asked to identify the type of function, the domain, and range for each one of these. So we're just going to see how well you did on these 8 functions here, and then we're going to look at 5 more functions. The first function is f of x equals x. The type of function it's a linear function. As you can see, it goes down and goes up, and this is the function that you were exposed to in Algebra 1 and Algebra 2. The domain and range is from negative infinity to positive infinity, and another way we can write this is all real numbers, and you may see it look like this with a R, 2 vertical lines and an R written like that. So that's another way of writing all real numbers. The next function is f of x equals x squared. The type is quadratic. Again, this is what you saw in Algebra 1, but moreover in Algebra 2. The domain is from negative infinity to positive infinity, and the range is from 0 to infinity. Notice the bracket by the 0. That it means we can include the 0, as you can tell on the graph here. We can include the 0 because on the parent function x squared, you can plug in 0 for x and get a value of 0. The next function is f of x equals 2 to the x power. This type is an exponential function, but it's moreover an exponential growth. Its domain is from negative infinity to infinity, and its range is from 0 to infinity. Notice that the 0 has a parentheses by it, and that's simply because the exponential function will never equal 0. And you're going to learn later about why it won't equal 0. And there's this boundary line that it approaches but never touch. And we actually talked about this in the function vocabulary, and we called it a horizontal asymptote. So you're going to understand why there's a horizontal asymptote at y equals 0. The next function is 1/2 to the power of x. It's also an exponential function, but it's moreover an exponential decay. Its domain is from negative infinity to infinity, and its range is from 0 to infinity. It behaves the same way as 2 to the x, but instead of increasing on its interval, it's decreasing on its interval. Next function is f of x equals absolute value of x, and the type of function it is indeed absolute value, like I mentioned earlier. The domain is from negative infinity to infinity, and its range is from 0 to infinity. Notice that it has the same domain and range as the quadratic parent function, so they behave in a similar fashion. All right, number 6, the function we're going to look at is 1 over x, and it is a rational parent function, and the domain and range are both from negative infinity to infinity, but look at the condition. For the domain, x cannot equal 0, and for the range, y cannot equal 0. And if you notice on the graph, we have these boundary lines again that the curve is approaching, but it can't cross. So again, when we get to the unit on rational functions, you're going to understand why there is a horizontal asymptote at y equals 0, and why there's a vertical asymptote at x equals 0. Next one is log base a of x. The type of function it is a logarithmic function, and its domain is from 0 to infinity. Its range is from negative infinity to infinity, and again, it's a boundary line that it's approaching where you're coming from the right side. And again, this is x equals 0, which is a vertical asymptote, and again, we'll talk about more about why there's a vertical asymptote there when we get to the unit on logs. Next function, square root of x. Type of function it is square root. Its domain is from 0 to infinity, and its range is also from 0 to infinity. Okay, students, we have just a few more functions we're going to talk about. They're not on your parent function checklist handout, so you might want to take out another sheet of paper and write these remaining functions down. Our next function is f of x equals x to the third. It's a cubic function, and its domain and range is from negative infinity to infinity. And this graph kind of looks like a snake. It goes through the origin, and it looks something like that. So go ahead and draw that graph on your paper as well. The next function is f of x equals the nth root of x, where n is an odd integer. And an odd integer, of course, is a number that's not even. So, for example, n can equal, say, 3, 5, 7, 9, etc. Okay. Again, this type of function is called the nth root. Its domain and range is from negative infinity to infinity. And of course, it looks also like a snake, but more flattened out like that. So again, go ahead and draw this graph on your paper as well. All right, so the next function is f of x equals sine x. It is read as sine x, not sin. It's sine x. And this is one of the trigonometric graphs that you're going to come across when we start the unit on trigonometry. Its domain is from negative infinity to infinity, and its range is from negative 1 to 1. Now, when we draw this graph, we have to understand that it's going to be like a wave. It's going to be like a wave, and it's a continuous wave, and it's going to oscillate between 1 and negative 1. And so sine always starts at 0. And it does something like this. Now notice I didn't put the arrows on it this time because it infinitely does this in the both positive and negative direction. So it keeps going on forever and ever and ever in the positive and the negative direction. The next function is cosine x, which is also similar to sine x, but there's a sort of shift with the sine function. You'll understand more about that as we get to the unit on trig. Again, this is a cosine function. Its domain is from negative infinity to infinity, and its range is from negative 1 to 1. It behaves similar to sine, except it starts at 1 as it oscillates. Okay, and so make sure you understand the difference between sine and cosine and where they start. The next one is this unusual looking function. It's read as int x. Int x. So you may hear it as a floor function or greatest integer function, and it's written like that. Its domain is from negative infinity to infinity, but its range is all integers only. And what that means is the output will only be whole numbers. And this graph is like a staircase of segments, and goes infinitely up. So it's like a staircase going upward, and that's what it looks like. All right, we get to our last parent function, which is f of x equals 1 over 1 plus e to the negative x power. This function is called the logistic function, and it's from negative infinity to infinity and has a range of 0 to 1. This function has two boundary lines, and one of the boundary lines is at 0, which is there, and then there's another boundary line at 1. And again, remember, we call boundary lines asymptotes. So it's kind of like the nth root function, but it's sandwiched between two boundary lines, between 0 and 1 inclusive. The only time we'll really see this function is when we deal with population growth, or you may see it in some of your science classes. This concludes the video on parent functions. Please make sure you are comfortable with all of these parent functions, as we will visit them each time we start a new unit. Also, you will possibly be quizzed or tested over all of these functions as well. So please make sure you study, memorize, and be comfortable with all of these parent functions. Thank you very much, and have a great day.